In this video for section 8.1, we're going to introduce sequences. Sequences are lists of numbers. Generally, the numbers are separated by commas. Each number in a sequence is called a term. So you can see an example of a sequence down here. You see that we have the commas separating the terms, and we use subscripts on the letter A to identify the term number n. An important thing to keep in mind when you're working with sequences: n is the term number. So for example, we say a sub 1 is the first term, a sub 2 is the second term. We use n, a sub n, this is called the general term, and it's often written like a formula, and we're going to see some examples of that in a minute. One example of a famous sequence is the Fibonacci sequence. In the Fibonacci sequence, the first two terms are both 1, and to get the next term, you add the previous two terms together. So the first 6 terms, the first term is 1, the second term is 1, the third term is 1 plus 1, which is 2, then we have 2 plus 1, which is 3, 5 plus 3, which is 8, and 8 plus 5, my next term is going to be 13. And you can see this written with the notation down here: a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So we're going to look at example 1 first. It says to write the first 4 terms of the sequence whose nth term or general term is given. And you can see here that the general term basically just looks like a formula. So for my first term, a sub 1, it's 3n plus 4. So that means I'm going to plug in 1 for n. So 3 times 1 plus 4 is 3 plus 4, which is 7. For my second term, I would plug in 2. So that's going to be 6 plus 4, which is 10. For my third term, I would plug in 3. So that's 9 plus 4, which is 13. And for my fourth term, I would plug in 4. 12 plus 4 is 16. For the next one, part B, this one is a slightly more complicated formula, as you can see here. So I'm going to start with A1, plug in 1 for n. In this case, there are 2 places to plug in n. So it's an exponent in the numerator and also an exponent in the denominator. So negative 1 to the first power is negative 1. And this is 3 minus 1, which is 2. So my first term is negative 1/2. My second term is negative 1 to the second over 3 to the second minus 1. Negative 1 to the second is positive 1. And this is 9 minus 1, which is 1 over 8. Third term, plug in 3. Negative 1 to the third is negative 1. 3 to the third is 27, and 27 minus 1 is 26. So negative 1 over 26. And my fourth term, negative 1 to the fourth over 3 to the fourth minus 1. Negative 1 to the fourth is positive 1. 3 to the fourth is 81. 81 minus 1 is 80. So what happens when you have this negative 1 raised to the power is it has the effect of making the sequence alternate between positive and negative values. Because when you have an odd number that you're raising to the power, then it's going to be negative 1. If you have an even number for the power, then it's going to be positive 1. So as you're increasing by 1, you're alternating odd, even, and so that makes the sign alternate negative, positive, negative, positive. So next you should look at checkpoint problems number 1. Do this in your notes, check your answers, and then move on with the video. Next, we're going to talk about recursion formulas. A recursion formula is a formula where instead of plugging in n, you're plugging in the previous term. So you can see right here, I want to find the first 4 terms of the sequence in which the first term is 5, a1, and an equals 3 times an minus 1 plus 2. So an minus 1, can make a note. This is the previous term. So if your current term is n minus 1 would give you the previous term. So for example, if you want to find a sub 5, this would be a sub 4 because 5 minus 1 is 4. And a sub 4 is the previous term to a sub 5. So to find the first 4 terms of this sequence, the first term is the easiest. It's 5. So there's no trick to that. They're just giving you that answer. So that's for free. A sub 1 equals 5. A sub 2, I would plug in 5 for a sub n minus 1. So this is going to be 3 times 5 plus 2. 15 plus 2 is 17. Then for my third term, I'm plugging in 17 for n minus 1. So 3 times 17 plus 2. 3 times 17 is 51. And plus 2 gives me 53. And then lastly, for my fourth term, I'm plugging in 53 for a sub n minus 1. 3 times 53 plus 2. 3 times 53 is 159. Plus 2 gives me 161. So next you should look at checkpoint number 2. Do this in your notes, check your answer, and then move on to the homework.